Okay, thank you everyone for making the time to join us in this webinar. I'm going to start the webinar now, and we've got a question section. Just in case you need to ask any questions while the webinar is carrying on, you can type them into the chat box, and we will take questions a bit later. So without further ado, I'm going to start. So welcome to the webinar. My name is Daniel, and it's based on an introduction of Fusion 360. So I guess the question or the message is here is, what is Fusion 360 and what is your understanding of it? And hopefully I can answer that as we go along. So looking at the agenda very quickly, I'm going to do a quick welcome and introduction to Baker Baynes and myself. Then we're going to go into Fusion 360 and who's it for, specifically the organizations that make use of it, so the larger guys, the smaller guys, and then you break it down into more detailed granular section, which is going to be the users, so the industrial engineer, mechanical engineer, electronics, the machinist or programmer. And then we look at the Fusion collaboration bit, we look at the extensions. Now, just a disclaimer on the extensions. Extensions are going to be presented in the upcoming series of webinars, so I will just touch base on it on this one. However, we're going to go deeper into it in the coming weeks. And then we look at the reasons why you need Fusion 360 as well as some of the extensions. There's a question section where we would answer the questions posed on the chat, and we'll do a closeout. Okay, so Baker Baynes introduction. Very quickly, my name is Daniel. I'm a key accounts manager on the process plant and manufacturing side of the business as Baker Baynes. I've been doing it for over 10 years now. I've been in the industry from working from initial purchase of the software to full-on implementation. I have a mechanical engineering as well as an Autodesk manufacturing and data management qualification, and my contact details are below should you need to get hold of me. So our solutions at Baker Baynes, we believe in a very unique adoption methodology that we've developed called iAdopt, which looks at three core focuses. Firstly, consulting, education, software and hardware consulting. Now, if we look at consulting itself, it's business process improvements. It looks at people, process, and the business itself. BIM consulting, data management, CAD, CAM, as well as simulation. On the education side of it, we're very big on the blended learning approach, which allows you to do either classroom training or self-paced learning on an online tool that we have called CAD Learning. And I'm sure many of you have seen it or accessed it in the past. Really, really great tool which allows for that blended learning approach. And of course, on the software side, we are an Autodesk Gold Partner, the largest Gold Partner in South Africa. We've got a Leica business that we support and sell, as well as a Clear Edge partner for the scan to BIM workflows. Now, just taking it into a bit more detail, you'll see on here the brands that we support, and I think from an Autodesk point of view, Cool Orange is one of the brands that we've taken on with regards to data management, so a plugin to Vault. So for the guys that use data management or Vault tools, a really, really nice tool to get yourself familiar with. So the industries that we serve are predominantly the building, civil, energy, process plant, as well as manufacturing. And I think today's discussion or webinar is going to be based predominantly on the manufacturing side of it, as well as the design. I encourage you to go in and like our YouTube page. You can also share and comment on it, preferably to subscribe, because you'll find that often if you have missed a webinar or a series of webinars, due to any circumstance, you can always go watch the catch up on our YouTube page. So if you haven't seen it before, or if you haven't watched any videos, please go ahead and have a look at it, like it, and subscribe. I'm going to launch a quick poll now very quickly, just to ask you a couple of questions very quickly on Fusion itself. So my colleague Amanda will share that poll with you now. Okay, so let's have a look at who is the capable users of Fusion 360, also who's it for. If we look into the areas that Fusion 360 solves, or the problems that it solves in different areas, we find that for the designer, yes, definitely it is for them, because you can produce 2D as well as 3D parametric as well as free-form models within the design environment. The engineer or the analyst engineer or even the electrical engineer as well has a role. Fusion 360 has a role for that department, given the fact that you can do very high-end simulation as well as PCB design. The manufacturing engineer and of course the CAM guys definitely uses Fusion 360 quite predominantly, as we see, because of the fact that you can do 2.5, 3, 4, and 5 axis machining with it, so milling as well as turning, and of course some plasma cutting as well in there. And not forgetting the programmer or the machine operator that would actually run the machine, create the G-code, or if they get the G-code off the design team, that's also part of the workflow with Fusion 360. Now, looking at the next bit, we notice that Fusion 360 has a very capable engine, as we mentioned earlier, with regards to being able to import 50 different file formats. So where does it become helpful? If you're using any file format that's non-native to Fusion or the Fusion platform itself, for example, step files, SolidWorks, NX files, or even some of the ASM files can come into Fusion if you need to use them downstream in tools like MoldFlow, NetFab for your 3D printing, or FeatureCam for machining. Or to be used in Inventor specifically, that could be facilitated using Fusion 360. Now, it has a very strong AnyCAD engine, as you can see. It'll take in your non-native CAD files, convert them, that can be used downstream. So let's have a look from a larger organization perspective. Now, you'll notice that the rate of change is quite dramatic within any organization, be it large or small. There's always competitive threats, so smaller teams, smaller companies fighting for the same business. Globalization is another thing. And of course, supply chain volatility present quite challenges on the design and supply market. If we look at it, we know that products are getting smarter, right? So there's, of course, a growth of opportunity here. We're trying to be more effective, more efficient, and reduce cost in our manufacturing, and of course, reduce errors within the supply chain. But we find that if we have a look at the daily operations, and this could be also for large and smaller organizations, we have a problem. Product development process looks like this today. And often we find that 30% of an engineer's time is wasted doing tedious tasks, like chasing down the right version of a file, for example. It can get messy, and of course, it can get complicated. But this process is painful and I'm sure very, very slow. This limits us from moving forward, getting products to market faster, and of course, that hinders the rate of survival. So what do we need to do? We need to change. There has to be a new way and a new way of doing things. And if we look at Fusion 360, for example, if we just imagine having a single designer or engineer in an R&D department, or even in a small business, engineers like to wear multiple hats, as we know, and in the past that meant multiple products. With Fusion 360, you can flex your needs based off your requirements, as Fusion 360 is fairly flexible and an intuitive platform that can be configured to customize your team size. You can use specific case workflows, adopt specific workflows for the teams that's tailored to the needs that's required, and you can access the full features for the specific departments that need it at the right time. Now, Fusion 360 is quite intelligent in that way, and it also helps with decision making. Tools like generative design, for example, it identifies thousands of different solutions to the problem that you define. You can simulate the performance of it, and also, of course, optimize the results based off your manufacturing capabilities. So, for example, if you're going to be using additive or subtractive manufacturing, you could choose which manufacturing methods to use to achieve the best results. Again, you can create a dynamic network with different aspects of the business. So the integration platform connects you to the entire product development and manufacturing ecosystem with a central cloud-based model, eliminating the friction between people, activities, and of course the machines. so teams can easily collaborate seamlessly of a single area, so the single source of the truth is maintained, and spend more time on innovation. And finally, if we look at it, how can Fusion 360 help the total organization? Fusion 360 invests in future of product development and manufacturing, catalyzing in innovation across all disciplines. So your team that has tools to automate mundane tasks, the ability to connect them to different aspects of the organization, be it managing supply network, access to the latest manufacturing technology, or having the product development cycle sped up throughout the process. By using Fusion as well as the extensions that support this workflow, you can achieve this seamlessly. Now, let's have a look and see where does it all come in. Fusion 360 is not just CAD, it's not just CAM, however, it's also not just simulation. It is documentation, rendering, electronics, all in one package. So you've got a variety of tools within one package that can allow you to adopt these workflows. And of course, it's available to you anytime, at any device and anywhere because of the mobile connections, the cloud connections, data saved on the cloud, collaborated via the cloud, and of course, it's also available to you on mobile devices like Android and iOS. And of course, cloud collaboration makes it seamless for using Fusion 360 within the organization. Now, let's have a look at a smaller organization. Again, similar challenges, business risk, volatility, as well as increasing costs are threats that we all face today, large and small. However, the smaller teams seems to have this issue, a constant issue that's been on their cases. Very similar to the larger organizations, we see that the organization map looks pretty much similar. Engineers, again, wearing multiple hats, and I'm sure sometimes you would agree with me that sometimes in a small organizations, engineers play just more than the role of an engineer. Some of them are quality control, some of them are engineers doing design, the drafts people, that responsibility falls under the engineer as well. So it gets complicated, and this process slows down quite a bit. Again, flexible needs. So Fusion 360's flexible and intuitive platform can be configured to team size. So in a user case, for example, and workflow, you can get access to the enterprise-grade features and services that you need, and you only pay for what you require. Again, Fusion 360's generative design can also aid in product development, speeding up of product development. So the development cycles and design iterations, and of course design intent can be translated across. And again, if Fusion 360 is adopted within the complete organization, you've got a single source of the truth to manage your data that goes across. So let's dive deeper now into the areas of specifics that we look at, and for example, the industrial engineer. So let's dive deeper into the areas that it would be used in. Now, the industrial engineer, for example, so for the industrial engineer, Fusion 360 improves workflow between design and engineering groups by offering a variety of modeling methods to meet each team member's needs. With stakeholders working on one unified CAD model, everyone shares information and ideas in real time, increasing efficiency throughout the project. And you can work in both 2D and 3D in one easy-to-use CAD system, supporting essential design methods with subdivisional, history-based, direct, as well as mesh modeling. The design intent is maintained no matter what stage of development that you're in. And you can see on here from a customer that has spoken about the integration and how the collaboration works within their organization. And for industrial engineer, we know that there are certain tools that are really important to them. For example, surface modeling and sheet metal. You've also got access to freeform modeling, mesh, as well as parametric modeling, as we a lot of us are familiar with. Looking at what can be designed achieved from the concept side of it, freeform modeling. So in here, we're reducing design time. Looking at easily creating complex surfaces, which sometimes can be a challenge, knowing that how do we manufacture it, how do we create it, and what type of surfaces are we using. Using Fusion 360 enables us to easily create this type of design work. And then, of course, capabilities, again, as you can see on screen, T-spline modeling, I think one of the more common tools that's been accessed with regards to some of the freeform modeling, and you find that with ease. Again, rendering has been quite a tool that's been used quite often, from what we heard of. Photorealistic images can be produced, and the beauty of this is that you can do it without having to physically create the prototype and take physical pictures of it. This can be done all off the virtual environment using Fusion 360 render tools. The capabilities, again, in here, stunning visuals. You can have different appearances, different finishes. So even before actual production, you can decide on what color, how the design will look, polished, matte, or the way the aesthetics of that model will look like. Keeping with aesthetic surfaces, so surface modeling is, again, a big factor within Fusion 360. So parametric surface modeling can be achieved. As you can see in here, you can bridge the gap between the concepts of functional surfaces, as well as flexibility to change how they behave and how they're going to work. Fusion 360, again, as some of you may know, is a fairly easy to learn tool with lots of knowledge available on that can help you move forward with your learning development with it. Again, it has traditional parametric surfacing within it, as well as areas to control surface textures and sketches. And of course, it is history-based surfacing, so you can go back and modify any history. From a prototyping side of it, you've got the test form and fit area where you can actually go in and do changes based on the form and fit that you're working with. Okay. And again, of course, it's easy to learn again, and you've got easy access to control surfaces to modifications. Integrations, again, on the capabilities, it has an integrated printing workflow. So if you're going to have to 3D print it, you can directly print it off the Fusion 360 platform. Again, you've got automatic part orientation, again, when you go in and put it into the printing environment, and of course support for plastic and metal printing machines is also available. So if you're using titanium, for example, as a printing process, perhaps a machine that does that type of work, then you could use Fusion 360 directly off the box without any modifications. So going into the mechanical engineering side of it, as we know that mechanical engineers like to push the limit with 3D modeling, and Fusion 360 allows you to do that, right? The products that are engineered using Fusion 360 include parametric, freeform, direct, and surface modeling again. So you can have history-based modeling that you can use. You can also engineer products with a comprehensive set of modeling tools, again, to ensure form and fit, to make sure that your parts fit the way it is designed and the way it's supposed to, so you can eliminate any other issues while doing the manufacturing side of it. You can solve engineering challenges, again, quite quickly with the simulation engine that's built into it that allows you to do quite a bit of simulation work inside of it. So you can test your designs to ensure that they'll survive. You know, it could be forces or any impact analysis that you may want to test. That could be done in there, and of course ensure that it behaves the way it should in a real life scenario. Now, just diving into it a bit, we'll find that, again, parametric modeling, I think quite a few of us are used to it, given the fact that we use other parametric tools. And if you're not, then it's a really, really great way to model using the parametric engine within Fusion 360. So again, history-based, so you could go in and easily track the changes that's been made to it. go back to it, reuse data, and of course, look at collaborating via the Fusion platform. Capabilities again, you're looking at 2D and 3D sketching, parts and assembly design is available, mechanism designs, so you can see actual movement to see how it's going to operate and work. Again, sheet metal components is also available within Fusion, as you can see on screen. You can do sheet metal covers, bends, etc. Surface modeling, as well as drawing creation for production. Looking at the mesh modeling, so we've also got freeform modeling in here. So some of the benefits, so there's no features or constraints, right? The translation is quite instant. It has a quick heal import. So if you're bringing in a model in that has to be healed, you can use Fusion to do the healing of that to ensure that it's stitched correctly, as well as there's preparations for 3D printing for downstream use. Again, capabilities, import 50 plus file types. So 50 plus file types is capable, provided that you are connected online to your account. You would import a file, it runs through the caching of it, and you would able to bring that file in Fusion for modifications. You can edit as well as repair, import a geometry, and of course import scan and mesh models into Fusion for working. Okay, and then we look at from an engineering perspective, if it's not a simulation side of it, if it's not simulation, you know, it's always something that we look at. So how does the part perform and behave in a real life scenario? And of course, this allows us to reduce physical prototype. We can pick up any issues early on in the design stage, either needs to be strengthened, and of course, we can reduce over engineering of parts. Again, the capabilities in here, pretty cool. Static and non-linear analysis is available. Modal analysis is available within Fusion. Thermal and thermal stress, buckling and event simulation. And of course, you've got access to do cloud solving, which is really great because it reduces the strain on the PC being used, right? So you can carry on working with your model while it does the solve. You get a notification telling you that the analysis has been completed on the cloud, and you can view the results. So that's very, very interesting. And of course, this is out the box in standard Fusion 360. We do have extensions that we'll discuss a bit later, which will allow you to go into further aspects of the design or simulation. Once again, Fusion 360 has a very powerful documentation tool engine built into it, and the guys that are familiar with tools like AutoCAD Mechanical, you'll find lots of familiarities with it. It has adopted a few of the Inventor as well as AutoCAD Mechanical engines to allow for that translation of the drawings from the 3D CAD model. Again, you've got smart templates in here, so you could have a template that you would use based off your company requirements, notes, sheet details, and you can export it out to DWG, DXF, as well as PDF directly from the drawing environment. The next bit, which is not so commonly used, is the generative design. And generative design basically means that it allows you to take your single design, you're allowing the application to create thousands of different iterations of the same part, giving you various ways of manufacturing. So it's also hybrid. It allows you for both additive as well as subtractive manufacturing methods, and you can pick the best form and fit directly from the dialog box. As you can see on screen on the right hand side, you'll see that there's quite a bit of different iterations of the same part, and it maintains a specific standard. So you would input in values like, you know, it could be material type, it could be the strength of that material, the form and fit, and the function of it, and you can pick the best design method of the suggestions that come out of it. Again, cloud solve, so you don't have to use your resources to do it. You can do it via the cloud, and of course the exports are editable files that you can work off and modify within Fusion. Okay, so let's have a look and see what it means for the electronics side of it. So For the electronics or the electrical engineer, comprehensive end-to-end workflows within Fusion 360 powered by Eagle CAD technology. So previously, PCB designs were done with Eagle. Autodesk had acquired Fusion a few years ago and acquired Eagle a few years ago and incorporated that technology within Fusion 360. And this allows you to quickly capture your schematic through automated controls and wizards, along with access ready to use component and content libraries. So there's quite a comprehensive library built in here. You can build on schematics by moving seamlessly into the PCB editor to build a workable board. You can use sophisticated but easy to use routing tools to map out the complex board, and that's done within no time within the PCB side of it. You can check circuit performance through functional tools like spice simulation for your schematics and simulating the thermal load. And of course, when combining mechanical enclosures with the circuit to ensure that the design meets desired guidelines, you can check how that board would fit in, if it needs to be moved out, if the placement or the mounting of that board needs to be adjusted. It's easily done within that environment. Again, you can validate your PC design, bring your designs closer to reality by creating manufacturing data quickly and easily, directly from Fusion itself, but also you can create a standard data from here, okay, for CNC data to be used in the PCB design side of it, well, the PCB board. And you can pick and place where the mounting and where the templates would go in, so it allows for ease of manufacturing. All this is brought together within the mechanical and electrical design groups within Fusion 360. So it's quite powerful in that sense. Going into it a bit deeper, we can see that within the electronics side of it, it's integrated. So we can add electronic components quite intelligently. We can ensure that the PC board fits, and we can use, there's a ready-to-use PCB library within Fusion that uses a lot of the Eagle technology that's coming into it. Some of the those designs or capabilities that we can achieve here is, of course, schematics, PCB layouts and routing, the integration, cooling as well, CFD, that could also be integrated within here, as well as the manufacturing. Now, let's go into it a little bit more deeper. So we've got here the PCB editor, and of course we know, as you can see on screen, it's real-time design checks by moving the boards. Anytime we move it, you notice that the connections are linked, so we ensure that everything is connected. And we've also got the ability to do guided and quick routing for single and multiple signals. That's in there. Again, you can see on screen how quick and easy it is to move stuff around and to integrate our board. So it's also time-saving capabilities in that as well. The integration of ECAD and MCAD. So ECAD, which generally is an acronym for Electronic Computer Aided Design, and MCAD, of course, for Mechanical Computer Aided Design. And in order to design intelligent products that integrate electrical and mechanical characteristics, it's vital that design and engineering workflows are also integrated. So ECAD and MCAD need to work together to ensure the true interoperability of the design and how that part will be manufactured and made, ensuring form and fit to ensure that the PC board aligns and it is properly positioned for cooling, etc. So 3D PCB, which is really, really cool. So you can make a 3D PCB design changes. You can do the changes in 3D with a 2D PC board, and it has an automatic update. So it is kind of parametric, where you have the updates that go across. You can evaluate how that board will look in real time. And of course, there's collision and interference checking in real time. It's quite capable, as you can see, with regards to the functional true 3D PCB design that comes out of it. And of course, the data properties set up, like the type of material and that's being used, it can be integrated within that. And of course, it's got an easy-to-use cloud-based workflow for simulation to check the thermal analysis on that to ensure that your board does not overheat. Again, looking at some of the electronic side of it, we've got a library in here, so there's an editor in there, and it's also it's fairly straightforward, where you can modify library content, easy 2D or 3D model creation with it. You can go into pins from past manufacturing data sheets, add that into it to ensure that you're keeping concurrent. Now, the specs of this are quite editable, which is great, because we find that sometimes you might be using data that is not available. All we do is we're going to go in and modify it. There's IPC footprint compliant calculator as well in here to ensure that it is compliant. And of course, data sheets from schematics pins are captured in here. And there's thousands of readable, available 3D parts and models that you can make access to. Again, you can create and manage team libraries to ensure that the team members are working on the right tools to avoid any delays. There's also a manufacturing data package documentation bit that comes with it. So it's basically one-click manufacturing data on creation, and then you have information that comes in, as you can see on screen. Documentation pulled through from the PC board has come into a drawing environment where you can have the information that live on the model put it onto a drawing to be used downstream. It's very configurable, the bill of materials, the pick and place, as well as how and where it's going to be on the drilling points as well. Capabilities is AutoCAM job loaded based on the GRC stackup that you would create on it. Easily customized CAM process, post processes, and the setup for that, as well as you've got a preview of how it will be manufactured. So that's looking at more the electronics, guys. So I think you probably realize that Fusion 360 is quite comprehensive and looks at fairly different parts of the business that you may be operating in. But what about the part that's generally not spoken about too much, the machinist or the programmer, the guy that's actually physically doing the programming? So what does Fusion allow you to do? It allows you to go from design to manufacture a lot quicker, right? So you can quickly import your design with the latest set of CAD and data translators for, again, 50+ file types. You can directly edit feature or model fixtures within the design environment, and that can be integrated into the CAM platform. So again, it's parametric enough, so if you do a design change, that change will be translated across to the CAM environment, and what it will do is it will give you a warning telling you that there has been a change to the design, so you've got to regenerate the toolpath, and of course, once that's done, you would see what the toolpath looks like. So toolpaths are fairly quick to generate. It's done in a couple of minutes. The setup is pretty much effortless. Autodesk provides quite a nice post-processor library, which we'll look at shortly. And of course, there's some very efficient jobs that can be set up, like the high efficiency roughing with adaptive clearing, for example, to simplify control multi-axis machine with specific tool orientation. Again, for the programmer, there's quite a bit that can take place. Let's look at some of the requirements or one of the availabilities that's available to you, the tools that's available to you within the CAM environment. So we've got 2.5, 3, 4, and 5 axis milling tool parts, right? And this is also positional and simultaneous milling. We've got turn mill or mill turn operations that can happen, water jet, laser, as well as plasma contouring, plastic, metal, and additive, so for your 3D printing, and of course manual and automated inspection. So if you're doing inspection, you can also have the setup within the tool. Now, some of the axis, so like the 4th axis, for example, is an extension if you're doing indexing or rotary action. So it's quite powerful, the workflow between both the model from the design to manufacture, and it's quick, easy way, so there's no exporting. You do it directly off the same interface. You just choose the workspace that you're working in, and you can take from your design to manufacture to get into the system. So again, you'll see on screen there's some setup that happens for stock, and then you can start adding your tool parts, your tools, and have that workflow run across. If we look at manufacturing itself, again, it's easy to translate. So data coming in, it doesn't have to be native data. It could be a step file, or it could be a file coming from a different CAD application. That will come in, translate quite nicely within Fusion, and then you can set it into the machining capabilities. Now, again, it's also fast and intelligent, knowing that you can stop if there's a collision. You can check the results of what it would look like in the toolpath, very similar to what you see on screen in here. So you can see some toolpaths that's being generated in here. If there's going to be a collision or the type of machining process that you're using. So you can see it's helixing in the example below. If you don't want it to helix, you want it to do a different operation, the plunge operation, you can double check how that's going to go from generating your toolpath. You can also see how that tool is interacting with the workpiece and if there's going to be any clashes as it goes along. Again, some of the benefits of it is you increasing productivities with more programming capabilities. You're reducing any risk of errors or machining or any crashes that may occur. And we know crashing a tool can be costly because you can break a tool in that way. Also, setting speed and feeds of how that tool path is going to run is also capable within the standard Fusion environment. Now, looking at the post processes, you'll find that it has a very comprehensive library, and as you can see on screen, these are just some of the post processes. Depending on the operation that you're doing, for example, turning or milling, you've got quite a bit of processes, post processes that's available to you directly off the Fusion library. Of course, we know no two machines are the same, so sometimes they might need adjustment, but most of the time not. And we can see that this is free to be accessed. If you require any changes to that, do let us know. We can also assist with modifying of the post. And looking at the second last bit, which is the collaboration side of it, how do you collaborate with Fusion, right? So we know that collaboration is key to the way we work. And knowing that accessing your data from anywhere is also key in today's days of manufacturing. So collaboration is essential to the way that we manufacture, to the way we work to have a seamless workflow. Now, we could collaborate the same data from design to manufacturing within the same organization, or alternatively, we could also collaborate our data with people that perhaps not sit in the same office, could be in a different part of the country or a different part of the world. So using Fusion, that uses the Fusion team, allows you to share your data, comment, and collaborate with intent so that everyone is on the same page and design changes are tracked efficiently. Now, how do we work with it? So in here, we look at, it's a browser collaboration. So as you'll see on the screen, you'll find that the Fusion's opened up in a design in the Fusion environment. That data needs to be collaborated out to someone outside of the organization. That can be pushed up, the data can be shared, and of course shared with specific rights. So only the right people access the data at the right time. Again, we can move it into a product lifecycle workflow with different integrations and different areas of how it will integrate. Again, data management setup, reviews can happen. This is based off live, real-time collaboration. So the data will live on the Fusion team. It's shared with a stakeholder that would need to access the data. A review can be made online, so there's no need to print, markup, or use manual ways to mark up. You can do it directly off the Fusion team itself. And of course, if you don't have access to Fusion, you can do it via a mobile device. Again, Android or iOS, that could be done. So if you're out on the road or on site and you need to do a quick design review, that can be accessed via the Fusion team link to speed up the process of design to review. Again, collaboration works quite nicely within the organization's firewall. You could have internal collaboration, and as soon as it needs to be collaborated outside, you can access the design by the Fusion team to share data with customers, suppliers, or design subcontractors that may be involved in the design. And that pretty much sums up the Fusion 360 workflow and the different industries. I'd like to just take a minute to show you the reasons why we would like you to look at Fusion. Of course, firstly, it's totally connected, so everyone's connected within the design workflow. It's flexible to your needs, and with the addition of extensions, you can have different capabilities for different team members to extend the workflow. The adoption rate is quite easy with it. It's got a vibrant community where you can get lots of information that's existing and lots of forums. And of course, you've got a very transparent development process that Autodesk has with Fusion, with updates coming out pretty often. I think it was on a 6-week basis where you'd find a new feature added or something that's been improved within Fusion. But I think one of the big things that I want to highlight here, Autodesk is currently running a promotion on Fusion 360 up until the 22nd of July, where you get 20% off the Fusion 360 license and 30% off the Fusion 360 extension. So if there's a need for it, please take advantage of this and have a chat to us after, and we can help you get you onto Fusion. So again, flexible options in here. So it's subscription based. You can add in the extensions as you need. So it's a annual subscription and 3-year subscription that you can subscribe to. It's on demand, where tools like the cloud access for simulation and renders would come into play. That's also using things like a token for you to do that sort of work and not use resources. The capabilities again is using the tools on demand when you need to. And just to have a quick squiz at what the numbers look like, Fusion 360 has been in development now for the past 8 years, and it has grown quite a bit. As you can see, the rate of growth is quite dramatic, in a sense that it's been improved quite a bit. There's a lot of features being added to it, and the adoption rate is growing quite significantly. And just to close off, you'll see that the workforce looks like this, right? So it's teams working on design, collaborating design to manufacturing to simulation, as well as to engineering departments within one organization, whereby you can collaborate your design intent and ensure that the design that's being manufactured is the correct one, that you worked on the right version. Community support, just looking at that, we've got quite a bit of community feedback with regards to Fusion and the types of design. So if you're unsure of what Fusion's capabilities are, you can have a look at it on the different platforms. The knowledge network that Autodesk hosts has quite a significant Fusion following and a Fusion page. There's user group meetups, and of course there's also expert advice at your fingertips. So just to close off, the future is here, and it's run on Fusion 360. And this is quite a challenge that we see, that the adoption to the new hybrid type of working has been a challenge of recent note, and knowing that you can collaborate real time with team members that perhaps don't sit in the same organization or the same office as yourself is sometimes a challenge. However, using Fusion 360 and collaboration tools allows you to collaborate better and ensure that your design intent is met. Now, I'm going to jump through very quickly through the extensions, now noting that we do have specifically tailored webinars coming up on the extensions. Just to give you a brief run through, we've got the machining extension. So this is for advanced manufacturing. The extension that's available, so 4th axis rotary indexing is available on this. We've got the nesting and fabrication extension. This is specifically for the sheet metal guys to do nest in here. So there's an extension that you can make use of. This is additive manufacturing, so metal manufacturing. So if you're doing laser bed or powder, or even generic additive manufacturing for metal, that extension is available to you. The advanced simulation extension is also available to you, which allows you to do more than just the standard simulation we've discussed earlier on. And again, the data management extension. So this is the Fusion kind of a PLM extension that you can use in here, which allows you to manage the product throughout the life cycle in the organization. And just to close off, with integration of very different types of technology, you find that using Fusion with extensions allows you to go further within your design and manufacturing processes. And please be on the lookout. We've got a webinar coming up on this that will give you quite a bit of insight into the extensions. Just to run through that, so we've got the Fusion product design extension that takes place on the 18th of August. We've got the simulation extension on the 22nd of September. We've got the Fusion machining extension webinar, which is on the 20th. And then, of course, nesting and fabrication in November, the 22nd. General design, additive manufacturing, and Fusion Manage will take place in 2023, January, February, and March. So we would like for you to join them, get a better understanding of what Fusion can do and the extensions, as well as look at ways that you can adopt them within your organization. If you want to get started, you can scan the QR code. I believe the links are on the chat box to having a look at what Fusion can do, or to get access to Fusion 360 itself. So you can do it via the QR code or the link on the chat box, and you can access Fusion to give it a test. So how can we help you? As you know, Baynes, we believe in solving our customer problems through digital transformation, helping you design and make a better world. Again, supported by our iAdopt technology, which looks at the people, process, as well as the technology and its purpose-built outcomes based off your environment. So I'm going to open up the floor for questions. If there's any questions, please put them onto the chat box and we can answer them as we go along. So just remember to note that the Fusion promo on extensions and the Fusion 360 licensing ends on the 22nd of July. So if you have any need for Fusion, please please shout and get in contact. So, question, why is Fusion so affordable? So I guess it is a tool that has its areas of limitations with regards to certain aspects. If you're comparing it to other 3D parametric tools like Inventor, for example, you don't have access to the design accelerators and you don't have access to the content center. However, Fusion has a McMaster part, which allows you to download content center, which is live. So it's content center that you can order the part, be the bolt, nut, or a specific component that you're looking for. Autodesk's methodology with Fusion is for the next generation of designers and engineers to make it more accessible for everyone to have access to the design tools. Okay, so I hope that answered the question. Okay, we'll wait for a couple more questions before we close it off. Alternatively, if you want to get in touch with us outside of the presentation or outside of the webinar, our details are on screen. So please feel free to get in contact, and we'll be happy to have a discussion with you regarding Fusion. So contact details are up on screen. Please let me know if you can see it. All right, so I'm going to end the webinar here. Please feel free to get in contact with us should you require a discussion around Fusion or the extensions. And if you have any questions, please feel free to get in contact and we'll be happy to answer it. Thank you for attending and have a great day further.